We shall now look at the sum of arithmetic progressions. Let's start by considering the series. Now, considering series here, this is our first term, and our first term is given by A. This is A plus D. This is A plus 2D. This is A plus 3D. And this is A plus 4D. We earlier stated that there is a fixed order in which the terms are gotten. How do I get 5 from 2? By adding 3. So our difference there is 3. I got 8 by adding 3 to 5. How can we work the terms from the opposite direction? How do I get 8 from 11? By subtracting 3. If I consider the last term, my last term is L. To get the term before L, I'll say L minus D. To get the term before this, I'll say L minus 2D. The sum of the n terms will be A plus D plus A plus 2D, right up to the term before the last term plus the last term. I can rewrite the sum from the last term. Sn is equals to L plus L minus D plus L minus 2D A plus D plus A. Now, if I sum all of this, now adding 1 and 2, this will give me 2 Sn is equals to A plus L plus A plus D. A plus D plus L minus D. So I rearrange, this is A plus L plus D minus D is 0. So I'm left there with A plus L, likewise plus A plus L, A plus L plus A plus L. I factorize, so A plus L occurs n number of times. I'll say 2 Sn is equals to n factor of A plus L. So Sn is equals to n all over 2 A plus L. This is the sum right up to the n number of terms if we are given the first term and the last term. But this, we can extend this formula further to include A and Z. We know that L is the last term, which is A plus n minus 1 D. So if I substitute this into this equation, I'll have S to the n is equals to n all over 2 factor of A plus n minus 1 D. This will give us n all over 2 factor of A plus A, 2A plus n minus 1 D. You can use these two formulas to find the sum. Now let's solve some problems concerning sums of arithmetic progressions. Find the sum of an AP with 8 terms, whose first term is 3 and the last term is 5. So I have here T1 equals to 3 and the last term is 5. What do I know? T1 is equals to A, which therefore means that A is equals to 3. I state my formula. The sum is equals to n all over 2 factor of A plus L. So I'll have the S8 will be equals to 8 all over 2 factor of the first term 3 plus the last term 5. S8 will be equals to 4 factor of 8. S8 gives us 32. Another problem. Find the sum of an AP with 14 terms. So n is equal to 14, whose first term t1 is equals to 7, and last term L is equals to 12. We're asked to look for S14. S14 will be equals to 14 all over 2 factor of T1, that is A, 7 plus 12. This is equals to factor of 19, which gives us 7 times 19 gives us 133. Given that 3 plus 6 plus 7 are in an AP, find the sum of the first 15 terms. I see here that my first term, A, is equals to 3, and my common difference, D, is equals to T2 minus T1, that is 6 minus 3 is equals to 3. So D is equals to 3. Now I've been asked to look for S15. I've been asked to look for the sum of the first 15 terms. What we don't need. Let me start by restating the formula. Sum of the first n terms will give us n all over 2 factor of 2a plus n minus 1 d. Here we are asked to look for S15. So this will be equals to 15 all over 2 factor of 2a, our a there is 3, plus n minus 1, which is 14, times d, 3. Now let's reduce this. The first 15 terms, sum of the first 15 terms will be 15 all over 2. This is 6 plus 42. Sum of the first 15 terms will be 15 all over 2 factor of 48. 2 goes there 14 times. Sum of the first 15 terms will be 15 times 14. This gives us 210. That is the sum of the first 15 terms in this AP. The first term of an AP is minus 8 and the common difference is 14. Find the sum of the first 20 terms. So T1 is minus 8. D is 14. Find S20. Now, our T1 is equal to A, therefore A is equal to minus 8. Sum of the first 20 terms will be 20 all over 2 factor of 2 times minus 8 plus 19d. Our d is 14. This will give us 10 factor of minus 16 plus 266. Sum of the first 20 terms will be equals to 10 factor of 250. So sum of first 20 terms will be 2,500.